Hello, today we are going to learn about the definite integral as the limit of a sum. So we had discussed that if the definite integral exists, then it can be expressed as a limit of a sum. So the definite integral, it can be written as in this way, okay? You can take this one as a formula where we are expressing the definite integral as the limit of a sum. So you either can write it in this way or you can either write it in this way. The only difference is that over here we are taking from r equal to 0 to n minus 1, and over here we are taking r equal 1 to n. So basically they are the same things, okay? They just differ in this index. And over here we also have that nh, it's equal to b minus a. So today what we are going to learn, we are going to see how we are going to calculate the definite integral by using this formula. So, but before that, you need to know that we have to use these four formulas, especially when dealing with polynomial functions, okay, as you shall see. The first one, okay, very easy. It can start from 0 to n minus 1, it doesn't matter. Okay, we can just make some modifications. All right, so this one, it is the first formula starting from 0 to n minus 1. Again, the second formula starting from 0 to n minus 1 of r, n minus 1 n by 2. And over here from r squared, summation of r squared from 0 to n minus 1, it is given by this formula. Similarly for this fourth one. Okay, but these formulas can be used when you are using this one, because over here everything is from 0 to n minus 1. But in case you want to calculate the definite integral by using this formula, then everything over here will change. Okay, for example, okay, let us just take a look at this one. R equals 0. If you want to use it in that way, then over here it should be r equal 1 to n of r. But over here instead of n minus 1, okay, it will be n. And over here instead of n, it will be n plus 1 by 2. Okay, similarly this one, instead of n minus 1 will be n. Instead of n, it will be n plus 1. It's like you are just adding n, you are replacing n by n plus 1. Similarly this one, you can write it in this way. Okay, similarly you can do it for this in a similar way, replacing n by n by n plus 1. Okay, so that is how we can shift from these formulas to employ here. We can shift them so that we can use this formula. All right, so with that being said, let us just head over to one exercise that I will do today. And I feel confident that if you know only this exercise that I'm going to do, then you will be comfortable in all the other exercises. Okay, so let's see. Okay, so the question is, evaluate this integral as the limit of a sum. Okay, I will write over here x squared plus 5x minus 2. Okay, maybe 3x squared dx. So over here you notice that, okay, as limit of a sum. Evaluate this integral as limit of a sum. Okay, so solution, it will start in this way. Fx, it is 3x squared plus 5x minus 2. Right? So a, it is equal to 1. B, it's equal to 2. And nh, it's equal to b minus a. Right? So nh, it will be equal to 2 minus 1, which is 1. So since we have calculated fx, now let us calculate fa plus rh. Okay, why exactly do we need this? Because the formula to express as the limit of a sum contains this term fa plus rh. So this one, you can write it in this way. Okay, a, it is 1 plus rh whole thing square plus 5 1 plus rh. Instead of x, you replace it by a plus rh. minus 2. And a, the value of a is 1. Okay, so you can write this one in this way. 3. Okay, you can expand 1 plus 2rh plus r squared h squared plus 5 plus 5rh minus 2. Then you can simplify. Okay, 3, 5, 6, 7, 8, 8 minus 2 will give you plus 6. Okay, r squared h squared, 3, okay, 3r squared, and then you can simplify. 3 into 2 is 6, 6 plus 5, 11, 11rh. Okay, so after calculating this one, now we just need, okay, I will write it over here that nh equals 1. So after simplifying this one, now we just calculate. Therefore, integral 1 to 2. Okay, maybe I will first write it in this way. A to b fx dx. Okay, it's equal to limit h tends to 0, and then you will be having h summation r equals 0 to n minus 1 f a plus r h. Right? So when a is equal to, when a equal 1, b equal to 2, so this integral will change into 1 to 2 fx dx. It will be equal to limit h tends to 0 of h r equal to 0 to n minus 1, and over here will be f1 plus rh. Okay, so this one also, since a is equal to 1, so it will be f1 plus rh. So what can we do now? Okay, I don't need this line anymore. So this one, okay, I'll continue from here to over here. Limit h tends to 0, it stays as it is. H, it stays as it is. The summation stays as it is. And f1 plus rh, it is this value that we have calculated. So it will be 3r squared h squared plus 11rh plus 6. Okay, so this is what we have got. So now we can just calculate the left hand side. This one stays as it is. Now this summation can be split up into 3 summations. 3h squared, it is a constant, right? It is a constant because it doesn't depend on r. Okay, r you cannot take it outside because the index over here is r. Whereas 3, it does not depend on r, so you can take it outside the summation. Similarly, h squared does not depend on r, so you can take it outside the summation. 3h squared summation r equal to 0 to n minus 1 r squared. Similarly, over here 11h summation r equals 0 to n minus 1 r. And similarly, over here you can take 6 summation r equal to 0 up to n minus 1. So you have taken 6, it will be 1. This is when we will have to use those formulas that I had given. So over here will be 3h squared. Okay, in fact, you can write over here 3h cubed. Okay, multiply this h inside. And over here, the formula for this one, if you remember, it will be n minus 1 and 2n minus 1 divided by 6. 11h squared. Right? So over here, we will be getting, and the formula for this one, it is n minus 1 into n divided by 2. And the formula for this one, it is 6n. And you are having h, so that is why 6hn. Okay. So now what will we do? Okay, now we can calculate the limit. Okay, but before that, we need to do one step. So over here you notice that there are 3 edge, and 3 ends. One edge you will multiply it over here. Okay, 3 by 6, it will give you 1 by 2. Okay, we can cancel. Now edge n minus edge. Another edge we will multiply with this n, so we will be getting edge n. And another edge that is left, we will multiply inside here. So we will be getting 2 edge n minus edge. Similarly over here we cannot do anything. Okay, over here there are 2 edge, so one edge will multiply here and one edge will multiply with this n. So we will be getting edge n minus edge, and over here we will be getting edge n. Okay, this one it's already expressed in that way. Now after doing this, we just need to substitute the values of hn. Hn it's equal to b minus a, right? So b minus a, okay, a was equal to 1, b was equal to 2, so we'll be getting 2 minus 1, which is 1. 1 minus h, hn will be equal to 1. 2 minus h divided by 2. Similarly over here we'll be getting 11 by 2. Hn it's equal to 1 minus h, hn will be getting 1. 6, we can write it in that way. Now substitute h equal to 0, you'll be getting 1. Okay, 1 times 1 times 2 minus 0 will give you 2 divided by 2. 11. 1 minus h will give you 1, and over here another 1, plus 6. Okay, we can cancel. You're getting 1. 11 by 2 plus 6. So finally you will be getting this answer 2 plus 11 plus 12. Okay, 12, 13, 14, 25 by 2. So this one will be the final answer. That is 1 to 2. Okay, that expression dx will be equal to 25 by 2. Alright, so with this exercise, now you can do so many exercises. Okay, but when the function fx is a polynomial. Alright, we can I will send another video. Maybe the next video is what happens when fx is not a polynomial. What happens if fx is a trigonometric, or fx is an exponential function. So that will be dealt in the next video. But for this one, this exercise stresses only when fx is a polynomial. Until next time.